To answer the first question, which compounds represents the acid and the base, respectively, we need to remember what a base and an acid is, and especially in a conjugate acid-base pair. We know that the acid has one proton more than the base in a conjugate acid-base pair. So here, when we look at it, KH2PO4, and if we compare it with disodium HPO4, we see that this compound here has 2 protons, whereas this compound here has only 1 proton. So therefore this must be the acid, and this one here is the base. So this is the base. And therefore we can with confidence say that potassium dihydrogen phosphate is the acid and the base is the disodium hydrogen phosphate, that's the base. For the second question, where we've been asked whether we need more acid or base to achieve the desired pH, what we simply can do is we just simply say, okay, pH is 6.2, that's the desired pH, and the pKa is 7.2, so this should be 6.5, sorry. And we know that when the pH equals the pKa, then our concentration of acid is the same as the concentration of base. And we know that from the Henderson-Hasselbalch equation. So if the pH is lower than the pKa, so the pH should be on the acidic side, pH acidic, we know that we need more acid. And likewise, if the pH is larger than the pKa, this has as a consequence that we need more base than acid. So with this rule, by comparing pH and pKa, you can very easily determine whether you need more acid or more base. So for question 3, what is the ratio of acid to base to achieve the desired pH? What we need to do is write down the Henderson-Hasselbalch equation. So pH equals pKa minus log of acid concentration, and I put that in brackets here, divided by the base concentration. So we have for the pH 6.5, pKa 7.2, and we are solving this equation for this one, for log acid over base in the first place. So we bring that to this side and the pH to this side, and we have log of acid over base equals pKa minus pH, just simply by rearranging this equation. So here we have 7.2 minus 6.5, and we get log acid over base equals 0.7. So log acid over base equals 0.7. Now we want to get rid of the log, and we know that we can eliminate the log by the inverse mathematical operation, and that is 10 to the power of. So we have on the left hand side, we have 10 to the power of log acid over base equals 10 to the power of 0.7. Now 10 and log cancels out, so we have acid over base concentration equals, and we just simply put that in the calculator and we get 5. We can write this as 5 to 1. So we need 5 parts acid and 1 part of the base to achieve the desired pH of 6.5. To answer question 4, how many moles of acid and base are required to make up the desired pH and the desired capacity of the buffer, we've just calculated that our ratio of acid to base equals 5, and we know that the acid and the base concentration should be 200 millimolar. So we have basically two equations that we can use to solve this question, and if we rearrange the first equation we find that A equals 5 times B, just by bringing that to the side. And what we can now do is we can put this into our second equation, and we can say our second equation is, instead of A, I write 5 times B plus B equals 200 millimolar, and 5B plus 1B, that gives me 6B, equals 200 millimolar. And the base concentration, therefore, B equals 200 millimolar divided by 6 equals 33.3 millimolar. So that's my base concentration, and for the acid concentration I just calculate equals 200 millimolar minus 33.3 millimolar, and therefore the acid concentration gives me 166.7 millimolar. So base 33.3 millimolar and 166.7 millimolar for the acid. Now for the last question, where we've been asked how much we need to weigh in, well, we need to make up our acid, that's the KH2, as we said earlier, 166.7 millimolar, and we want to have 500 milliliter of that, and we have a molecular weight of 136.09. So we can say for the acid, we do dimensional analysis, so we want grams, and we have, let's do it like that, we have the unit gram is in 136.09 gram per mole. So the gram is good, but we need to get rid of the mole. So we have that in 166.7 times 10 to the minus 3 mole per liter, and we have that in 500 times 10 to the minus 3 liters. That's our 500 milliliter. So liter cancel out, mole cancel out, and what we have got left is 136.09 grams times 166.7 times 10 to the minus 3 times 500 times 10 to the minus 3, and this gives us, when we do this calculation, this gives us 11.59 grams. And now we can do the same thing for the base. So here for the base we have again the molecular mass is 142. So grams, 142.1 gram per mole times 33.3 mole times 10 to the minus 3 mole per liter times 500 times 10 to the minus 3 liters. Liters cancel out, mole cancel out, and we do this calculation, we get 2.37 gram of the base that we need to weigh in. So I hope this makes sense, and thank you very much for watching.